In this video, I want to take a look at a physical transformation that takes graphs in rectangular coordinates and turns them into polar coordinates. And it turns out that it's equivalent to one of those folding Japanese fans. If you think about how they open up into a fan, there's a pin in the middle that holds one end together while the other end has unfolded. Well, if you could take the pin out and open the fan up, it would open up into a rectangle. It turns out that that transformation is exactly the transformation of going from polar coordinates to rectangular coordinates. Or if you did it in reverse, start with a rectangle and fold it up so that it comes together in that fan-like thing, you would be taking rectangular to polar. So what I have here is I have r equals 2 cos theta plus 2, and I have it graphed sideways. So I'm thinking of the theta axis is running this way and the r axis is running that way. So the cosine is maximum here at when theta is 0, and then it gets smaller. Well, actually, how big does it get? It gets as big as 4 here, right? And then it comes down to 0 at the ends. So I'm looking from minus pi to pi on that chart. Okay, so it's all tipped sideways. And I have it tipped sideways because I want this direction here to stay my theta equals 0. That's the direction theta equals 0 is going to have. And so theta equals negative pi here is going to have to turn around until it gets pointing in the other direction, likewise here. So what's going to happen is each one of these horizontal lines is corresponding to a constant value of theta. So they're going to turn into radial lines of polar coordinates when I click on it. You ready? Here we go. So what's going to happen, before I do, these are going to all scrunch together because this is all where r is equal to 0. So all of the points here are going to scrunch down to the origin. And these horizontal lines will correspondingly be fanned out into radial lines. So there we go. So notice how it's scrunching down to 0 there. And all these things are stretching out. And what happens, if I can stop in the right spot, right? You've now transformed into polar coordinates. And the graph is now a cardioid. Watch that again. Ready? Go. This is a transformation of rectangular coordinates into polar coordinates. It is a Japanese folding fan. And the thing that I can do is I can do all sorts of interesting things here. Let's let it click one more. There we go. Let's shift it down with maybe some negatives here, right? I'm going to show r now from -1 up to what's as big as it gets there. Must be 3. Okay. So we're just going to look at that much. Still, the axis down through the middle here is what gets scrunched to the origin. That's where r equals 0. So here we go. The negatives actually get turned around to form that inner loop by the time you get there. I'll stop it when it gets to the... Right. The negatives have to get turned in backwards to make that inner loop. Right? I find it really fun when you start doing some things with maybe multiple loops here. So actually let's go with a little bit bigger here. How about 4? So, and maybe a smaller shift. There we go. So there's a amplitude 2 cosine curve with period 2 pi divided by 4, so pi over 2. I'm plotting it from minus pi to plus pi. It's been shifted up a half, so the positive sides are a little bit bigger than the negative sides. And when we fan that, well, we rotate that around, it turns it into that. That's just fascinating to me to watch. Here, let's try. Um, let's try one of the odd ones. Let's go with a 3 right here, right? Where the loops end up on top of each other. So it starts like that. You got positive loops, you got negative loops, right? The axis is running right down through the middle there. Remember, this is all sideways from the stuff we've done before. So R is going this way, theta is up and down. Go. Positive loops are getting looped around. You can see the negative loops forming, coming in. And there they go. All right. It would be interesting to make a physical model of a Japanese fan, or to get a fan and pop the middle peg out and see if we can actually do some polar coordinates on it. Anyway, there you go.